Like if you're using like a BankID, you have to go to the bank and show your passport. Well, if you're using Google, you just set up an account. So you have different layers of security there, but that's really dependent on the service. But we're going to focus on the OAuth 2 framework, which is actually all about delegated authorization. With delegated, that means like, and a good example of that is you have an end user who's using an application. It can be a mobile app, for example, and then that application wants to talk to Google to see like your emails, or then you kind of delegate the authorization to the application, saying, yes, it's okay, this application can access these resources on my behalf. And then you, and that's built on top of, it's like it is a protocol built on top of HTTP, but the reason we often call it a framework OAuth is because it got so many optional components. Different services might offer different features, and that's also part of why it can be a bit confusing, because and if you're building your own OAuth authorization server, then you need to know what features you want to use or not, and there's lots of like optional things that are required. So if you integrating towards another service, you should really just read their documentation and see what path they're offering. But you need a basic understanding of what features are available, and that's what we're going to talk about today. Then there's the OpenID Connect. This is like an identity layer. It's more like a, it's usually called a protocol because it has more requirements and more than OAuth does, and that's all about identification, as I said, about authentication. And it's like it's a layer built on top of OAuth 2. So we're actually going to focus most of this talk on OAuth, and then we're going to talk about OpenID Connect a bit in the end. There is an OAuth 1. That doesn't matter. Don't read about it. They're not compatible at all. Just start with OAuth 2 directly. You should never use OAuth 1, so it's a mess. Anyway, so OAuth 2, this is not an extensive list, but there's a lot of like this is specification, most of them. Like the top one there is like the main one, and then you have like then there's lots of other specification building on this. So this is those long technical documents, and it's not where you want to start. Once you kind of like work with it for a bit, you want to go more in depth. But of course, if there is a certain flow, as we're going to see on later, or that you're going to integrate, then it could be helpful to like go here instead of just Google, is this required? Because it's going to say if it's required, and they're actually really well written. It's just that they're a bit overwhelming if you start there. And the last one's there with about security, best current practices. That's always good to read. If you're writing for native apps, I will definitely recommend checking out the OAuth 2 for native apps. So OAuth.net, that's like the official site, where I have linked to all this documentation. And we're going to share the slides after the presentation too, so don't worry about that. And then it's OpenID Connect. You have the core component, the discovery component, which is optional. The core one is, of course, not optional, but it's just like there's a lot of documents. That's what I'm trying to say. So yeah, OAuth 2 is an industry standard. Lots of well-known services use it, like Microsoft has in their Azure Active Directory, they have support for OAuth. Google Identity Platform uses it. If you want to access Google's APIs, you have to use OAuth. Or they have some other, Spotify uses it, Twitch uses it, Discord, that's a chat service for the people who don't know, PayPal uses it, Imgur, which is like an image sharing service. There's lots of services that use it. So you should really, it's not just something I'm making up because I think it's cool. So this is my social network. It's a fictional social network, very original name, but they're like a startup. They want to have some cool features where you can go to your profile site. So this is they want you to be able to share your playlist on Spotify with your friends, basically. So what they do, this is the first approach. They say, oh, just give me your username and password for Spotify. We will log in and we'll read your playlist. And yeah, I'm sure that most of you are agreeing that this is not a really good idea. Because, like, how do they even store the credential? Because they probably want to store the credentials because they want to go and fetch your playlist again and again and again. I mean, they couldn't really hash it because they need the actual password when they're going to send a request to Spotify or log in on your behalf. So they're probably going to store it in plain text. Maybe they do some kind of encryption, let's hope. And if they have a data breach, yeah, your Spotify account is going to be compromised. Someone's going to steal it. You don't want that. And then it's the last thing. How can you be sure that they only read your playlist? I mean, they could add stuff to your playlist, or they could, they could easily just sell your account, but they can do whatever. They say they are only going to read your playlist, but you don't know. Luckily, Spotify is smart. They use OAuth, and OAuth is coming to the rescue. It might be a bit hard to see here, but one of the advantages, the end user is usually authenticated, like they redirected to Spotify, not in all cases, but in the most common case. So Spotify also then works as what's called an authorization server, as we're going to see later. Like, you trust Spotify with your Spotify password, obviously. And it's really easy for the end user to verify that, looking at the URL address too, like yourownaccounts.spotify.com or something like that. So you feel safe giving your Spotify password to Spotify, obviously. And instead of then receiving like your actual credential, username, and password, my social network in this case will just read an access token, which is kind of like is a limited type of credential in a way. OAuth also allows us to limit which part of the applications. It says here you have to agree that my social network can view your Spotify account data and view activity on Spotify. And you've probably seen lots of those forms already. But that's really great because you can, in some services, you can choose exactly which grants you want to give. And last, OAuth also allows us to revoke the third-party application's access to the account. Meaning that if you suddenly don't trust this service or don't want them to have your access to your account anymore, you don't need to trust that this service, my social network in this case, deletes your things because you don't trust this service, or maybe they just keep it in a backup database or something. You can simply revoke the access token going into your Spotify account on Spotify, and then it doesn't work anymore, it's invalidated. So that's really great. So a little bit of roles in OAuth. You have a resource owner. This is the person who kind of owns the resource, or at least grant access to a resource. A resource in this case, meaning either like a data or like an operation, usually something you can do via an API that's exposed. So the best example of this is usually an end user, but it could actually also be a client. Could be a resource owner itself, but today I'm mostly when I talk about it, I usually often use end user, but it is actually a general resource owner, so just keep that in mind. So a client is usually an application, some kind of website, a native app. It could be a desktop application. It's any kind of like application that wants access to your stuff. So the client then requests access to a resource on behalf of the resource owner. And then you got the resource server. This is usually often exposed over an API. This is where your data is. And then it's the authorization server, which is kind of it can authenticate the resource owner if it's an end user. It can also authenticate clients, making sure if the client can kind of say yes, it's me, and have their own username and password. And it's also the one that issues access token. And the resource server will also often talk with the authorization server, but that won't be common talk. And sometimes the resource server and the authorization server is the same component, but it doesn't have to be. That's why I put a little box there and not there. So just be aware that in Spotify's case, it's both an authorization server and a resource server, so it has both. So the generic OAuth tool flow. So the client usually then requests an authorization grant. This is not the same as, and then the resource owner say, yeah, sure, you're allowed to do this. You're allowed to read my playlist. But authorization grant is not the same as an access token. Authorization grant is just some proof that the client has that the end user, for example, has given access. It says it has to prove that the client are allowed to access these resources on my behalf. But it's not access token itself. You can't go to resource owner and say, oh, look, I'm allowed to do this. that proof is actually used to the authorization server. Because the authorization service can recognize that proof, or the authorization grant, if you want. The client then contacts the authorization server, and they say, sure, yeah, this proof looks okay. And then he returns an access token. And then the client, in the end, uses that access token to talk to the API, talk to the resource server, and it gets some data back, or it gets some confirmation, and so operation was done. So that's a very, it's just an overview of the general flow. As I said, clients need to be registered at the authorization server in most cases. You can have unregistered clients, but it's a bit out of the scope of this talk. But normally you want to register the clients with general client information, like the name, like that's up to the authorization server and what kind of features they want to support. If you're using the authorization code flow that we come back to in a minute, then you need to register lots of redirection URIs, and also the type of client. And this general two categories of client. We talk about confidential clients and public clients. A public client is a client that can't safely store client credentials. I talked a bit about it before. Because the client is registered with the authorization server, the authorization server can give it some kind of credentials so the client can prove that it's the one making the request. In most cases, this is like a client ID and a client password. So it's almost like a username password flow. But it could also be like a public-private key pair, really depending on the authorization server. But in most cases, it's usually like just a client secret of some sort. But public clients, they can't really store it securely. What do I mean by that? Well, like pure JavaScript front-end applications, pure native applications like on a phone without any backend, like it's stored on the device. It's people who know what they're doing they're going to manage to access that information. And also Internet of Things devices. You can have smart light bulbs that might use OAuth, but you can't really trust them with like a password because someone's going to manage to hack that by sniffing on the Wi-Fi, and people do this. And then it's the confidential clients. Those are the clients that actually can store the password safely. Usually, like a web application, for example, have a web server where you can store your secrets. They're not leaked outside. They're not exposed to any in a browser or to end user in any way. They're not sent. Confidential clients is really what you should aim for if security is your most important thing, and it should be. But yeah, it's basically everything that has some kind of backend. And even like if you make a native application, you usually have a backend, so you should probably you can probably support that. And that's a bit point in this presentation too. Like there are flows that are only for public clients, but if you can use the flows that are for confidential clients, you should always use that if you can. So I'm going a bit quickly just through some vocabulary too, because there's all kind of different levels of expertise here. So scopes, that's just a list of strings basically based by authorization server. But what they do is like, it could be stuff like, okay, like you see Spotify here, playlist, read, collaborative. And they define like what that scope is going to do and what kind of like resources you then get access to. Or Gmail and Microsoft as well, they use like full URLs. It doesn't really matter. Like you should just go and look at the documentation of the service you integrate. Or if you make your own service, then you decide what the scope's going to be. So it's basically just a list of strings that the client can use when it kind of initiates the flow and say, okay, give me access to these things. Then you would send in those scopes. And the authorization server might like say, so if the client can say like, oh, give me read access and write access. And the authorization server might say that, well, this is very sensitive data, and your client is actually not approved to have write access no matter what. So the client can request to get access to both, but the authorization server can say, no, you only get one of them. And usually then in its reply, it just tells you which one you actually got. And also the resource owner might affect it. We saw in some cases you can say, okay, you give access to this and this and this, but not this, and like often a checkbox, or not always, but the resource owner can affect which scopes actually return, and that could be different from the one that was asked by the client initially. Yeah, so access tokens and refresh tokens. They are also strings. There's lots of strings. And they, as I said, there's kind of like the key card that kind of says what the scope of. They tell the resource server like the scope of your authorization, like what you actually have access to. The kind of the temporary credentials for the proof of what the resource owner given access to. And often in the form of a bearer token. I'm not going to go into specific with that, but most of you who have talked on API use the bearer tokens and access tokens. And it can be a reference. It could just be like some kind of random string, but it can also be self-contained and have some additional information, like a JSON web token. But normally the client shouldn't really care about what's inside the access token, because it's just something it uses when it sends the request to the resource server. So it doesn't really matter what's inside it, in most cases. And it's usually short-lived, and that's a really important point about the access token, that it is short-lived. It shouldn't live too long. If you want, if you have a confidential client, you sometimes will get a refresh token as well. If you have a public client, you won't. But a refresh token is basically, instead of asking the user to authenticate again and granting everything again, you can just generate new access token by just sending the refresh token to the authorization server. But that's only for confidential clients, because that communication then is happening on a back channel, like server to server. It's not exposed anywhere, and it should be encrypted with TLS. I mean, or over HTTPS, that is. But yeah. I think that was everything there. Yeah, and they can be revoked by the resource owner at any time or the authorization server. So if you invalidate an access token, the refresh token usually it's all gone away. So the access token and refresh token, the client will then store that somewhere in the system, so that he can easily access it. But yeah, I talked a bit about authorization grants, the proof, the first thing you do when you go to the resource owner or the end user, for example, and you say, "Give me can I have access to this?" And there is different ways to giving this grant or this proof. And these ones are sometimes called flows, because they all have a defined kind of like flow or procedure you go through. The best one is the authorization code flow. It's for confidential clients. It's the most. It has a bit extra steps, but it's really worth it. And in this flow, the access token isn't like exposed on any front-end channel. Then the implicit flow. That's for public clients. You shouldn't really use it. It's a bit outdated. But the reason I mention it here is that a lot of existing OAuth platforms support this kind of flow, and you might even be used to be yourself if you're familiar with the field. Instead, you should aim for the proof key for code exchange authorization code, which I'm going to also talk a little bit about. Then there's a client credentials flow. That's just sometimes the client have access to resource itself. It's his own resource owner in a way, and it basically just means, if you want to access some data, then you use that kind of flow. It's basically just asking for a token with your own credentials. And then it's the resource owner password credentials flow. That's a long mouthful. Don't use that. This is something that was created, and I think it's because if none of the other kind of like ways of getting a grant isn't possible, it's a suggestion that's slightly better than giving away your username and password. Because in that flow, you actually are giving away username and password. But the whole point is that you're only doing it once, and then they get an access token, and then they use that instead of asking you for password or storing your password. But yeah, you shouldn't really use it. Usually, you can use any of the other flows. So yeah, don't use that one. I'm just mentioning it for completeness. And if you're doing like Internet of Things kind of things, there is a specification for that too. It's called the device authorization grant. I'm not going to go in detail on that one. And that's because it's very niche. But if you are making kind of smart devices and stuff which can't have a backend for some reason, then you should really check out that document. So those codes behind there that just reference to those specifications that we were talking about earlier. And yeah, you can just search for them and you find them. All right, authorization code flow. This is, as I said, for confidential clients. And this is basically if you can use this one, use this one. It's not flawless, but it's the best current alternative of the standard. So it usually starts with the user clicking some kind of button, like connect my, or grant access or whatever. And then the client then redirects the user to the authorization endpoint, which is some kind of URI the authorization server has given you, the client. The authorization server will then redirect the user to some kind of login form. It authenticates the user, and the user kind of grants authorization. It says, "Okay, allow this." This is like those figures I showed earlier, and we're going to go through each step more in detail. So hang with me. The user is then, after it's authenticate itself and say, "Yes, I agree that this client can get access to these services," then it's redirected, the user, and is then redirected back to the client. And all these kind of errors I've shown so far are happening in the user agent. So this part of the flow is visible for the end user sitting on his computer. Like, you can see it in the browser history, or at least in the network traffic. Then the client has gotten this authorization code, and the authorization code is the grant I was talking about. It's just some code that the authorization server will recognize, some random kind of string, and it has to be crypto safe. But it's very short-lived, extremely, like much less than the access token is. But the client then can do a post request to the token endpoint of the authorization server. And the whole point about, and the reason this flow is more secure is that you see everything, I drew it here with like a white arrow, is that this is actually happening on the back channels, machine to machine over a secure connection. It's nothing that happened in the user's browser. It happens somewhere from web server to web server. So that's much, then you know that it's kind of like, it's safe. And then if everything is okay, the authorization server will, of course, go through and like check if this code is valid, that it hasn't been used multiple times. That's an important point. Like if someone steals your code, it can only be used once. The authorization server aren't going to allow you to ask for a token again with the same code. So that's also quite important. But the authorization server then returned that access token to the client, and this is not part of the flow, but I'm showing it for completeness. Then the client can then do requests to the resource server, like often like a bear token, talking with the API or whatever, and get the data or do the operation. So yeah, so let's start with this this first part over here when you are initiating the request. So what you usually do, you just do a redirection. Like it could be a simple GET request directly. Response type. So this is not all the parameters, and every different authorization server might offer extended parameters there, but like it's usually just given in a query string. And this is visible in your browser. You can go with the network history and look. But response type equals code. That's something you have to do because you're basically saying I'm using the code authorization grant so that the authorization server recognizes that. Then you have the client ID. That's something you got when you registered your client. In this example, it could be my social network, for example. And then it's a redirect URI. So in this step, when the authorization server redirects back to the user, it needs to know where to redirect back. So that's that redirect URI you registered. And you couldn't have multiple, but like normally you just use one. So that's some kind of so they knows where to do the callback. Then it's a scope I talked about earlier. Which scopes do you want to have access to? And I mentioned the state parameter. It's not required, but I really recommend that you use it all the time. It's basically because both for your own part, but also for mitigating cross-site request forgery. So basically, the state parameter is just some random value again. This looks like a GUID. It's not the best way. It should be more safe than that. It should be crypto safe. That's just a general expression of saying use some kind of, it's outside the scope of this talk. But it should be something that can't be easily recognized or guessed. And it's also when you're redirected back, we're going to see that that state comes back. So that's actually the state when you do the request, you should save the state somewhere in your session management on your server. That's also because that callback we're talking about earlier, when that happens, if you don't recognize the state, because the authorization server is going to include that state, then you know that it might be just someone else trying to send you stuff over that endpoint, because it's open endpoint. I'll come back to that. But yeah, and don't worry if I'm going a bit too fast now. All these slides will be available, and you should also check out there's lots of great blog posts, there's lots of great videos. Try to get a different approach. So yeah, so the next step after we have kind of initiated a request is that we redirect it to the authorization server. It usually authenticates the user, and then it also usually it verifies the authorization. Like, is it okay that it says like my social network? It's okay that my social network gets access to these things. Sometimes it doesn't need to ask you, but that depends a bit on like the service. Where you see, and here's what I'm talking about, the redirect back to the client. It's usually just a 302 redirect. And you see this also is visible in the browser. So you can, if you use any service at all, go into the network history and look at it, because it's quite fascinating. But yeah, there's a state coming back to you. So it's the same state parameter you started. You can have multiple requests, so you might want to know which request this is linked to. But that state, you should really just check that you have it, because if not, everyone can do a GET request to this address with own state parameter and some random kind of code. So yeah, use the state parameter if you can. And then you could, of course, like the access could be denied. The user could click cancel, or you're not really allowed you're not really registered, or yeah, or the user could say like, no, I don't want to grant this client this. Then you get an error, and this is some access deny is the most common one, but like it could be a server error, it could be loads of things, and all those are defined in that specification, and yeah. And then it's a token request. So now we're back on the server side. You have this authorization code, which is also just a random string, hopefully safe, can't be guessed. But that's created by the authorization server. So what you want to do now is you want to change that code into actually an access token you can use. So this is a server-server communication of a secure connection. And this is what specifically reason that this is a more safer approach to this is that the client actually needs to provide some kind of credentials. You can't just send the code and then just get it. You have to authenticate yourself, or like, sure. So here's an example. You do a post to the token endpoint. And here's the essential part. This is just using some kind of client username password authorization. For the people who are not familiar with like the basic authorization header, this string here is actually just a base64 encoded, where you have like the client ID, then a colon, and then the client secret. So everyone can read that, because you could just convert it back. But this communication is then happening on the server side, so hopefully no one will read that if you use a secure connection, which you should. But yeah, there's another way to do this. You could actually include the client ID and secret directly here. But the way you authenticate yourself with a server depends. If it's a public and private key pair, this would be a different approach. But this is the most common way to either use a header or put a client ID and client secret in your query parameters there, or in your form, I mean. So yeah, the grant type must be authorization code. The code is the code that you received. The redirect URI, you actually have to provide that. That's just an extra safety measurement. I don't think you need to provide a state. I'm sorry, I think that might be a mistake on my end, actually. So just ignore that part. Yeah, and then you get the response. Like the authorization server, they clearly have to authenticate you. They have to check that your username and password is correct. The client's username and password, that is. It verifies that the code is still valid, it hasn't expired or you used it before. Ensures that it was actually issued to that client. Because say that I have one client and then someone else has a client and they also generate a code. You don't want them to like be able to then like generate codes for my client, like, and vice versa. So the authorization server should do all this for you. But it is important if you're setting up your own authorization server that all these processes are done. And like if you are setting up your own authorization server, for example, protecting your own APIs, you should use like existing framework, like for .NET, like Identity Server 4, for example, or Keycloak if you're using Java. Like you're getting a lot for free, and you can't really do it safer than they already done usually. We use a well-known service if you're setting up yourself, but it's good to know what's actually happening. Yeah, it verifies the redirect URL, it returns an access token, and usually a refresh token too if you're using this flow because it's safe. So yeah, this is just a response. You have the access token, some kind of string, token type, can be anything, usually a bearer token. This meaning that when you authorize, you use the bearer authentication route, you use the bearer in the authorization header. When you talk to user server, it has an expiration date, which is useful because you need to then you can save this and then you know like, okay, has it expired now? Okay, then I need to ask for a new token, refresh token, or if you don't have refresh token, you have to initiate the whole flow again. Yeah, it provides a list of scopes. That's not always, but it does that if it has given different scopes than the one you requested. Maybe you didn't get access to everything. Or maybe even added some scopes, which can be if the authorization server is configured to always give some scopes without you requesting them. So you should check this list. And the authorization server can also add like their own kind of additional parameters to this that could provide you additional information. But that's really up to the service you're connecting to. So yeah, read their documentation about it. Yeah, that's authorization code flow. And again, I know we're going kind of quickly through it, but yeah, watch through the slides again. And feel free to ask any questions at the end or after this talk as well. The client credential flow, as I said, is just when the client directly wants access to some resources that it has access without any end user involved. This could be, for example, like, take the case of, since I used Spotify a lot, maybe they have some kind of like way of you to get information over an API to information about the top 100 listened songs in Norway. I don't know if they do actually, but imagine they do. Then you might just have to be authorized to a client. So basically, you just provide your client credentials. Again, I've done it through an authorization header. It could also just be in this list, client ID and client secret. You do this on the back end, so you don't need to worry that it's exposed anywhere again. And you say which scopes you want access to. And this is, so the client credentials flow is actually very simple. It's just a token request, basically. Yeah, and then you get your access token. All right, implicit flow. So this is intended for public clients. But this flow was actually created at a time before we had, actually I have got on the next slide, so I'm going to take it then. So you have no backend web server. It can be a single page application, for example. And therefore you can't have no, so the flow is kind of the same. You redirect to authorization endpoint happening, everything here is happening in browser. You authenticate, you get redirected back. But here's the big difference. So the access token now is actually returned here. There's no, because this client is public, it has no way to do any backend communication, like server to server communication. So instead of returning an authorization code, it actually returned the access token immediately. And hopefully you can see that this is exposed in the user agent. So you as a user can see that access token. If someone got access to your computer somehow, like some application you install some, then it's potential that they get access to this. But there is one important thing here, and that is actually sent not as a query parameter, but like as in the fragment part of the URI. So that means that the request is actually not sent in the request to the web server where it's hosted, and it's only available for the user agent, meaning the browser. So the JavaScript in browser can retrieve this, but it's not sent over the network, meaning that to the server. So it still stops people from maybe sniffing it up, but unless they have access to your browser. But yeah, I'm not going to go too much in detail because you shouldn't really use this. But you should know about it because there's a lot of services that still support this. So yeah, and the rest of this flow is the same. But yeah, let's look at some security concerns. It is a legacy solution. It was made before we introduced cross-origin resource sharing. That is, before front-end application couldn't do requests to another service, like post requests, for example, that was outside its own origin. So you remember in the authorization code flow, you do a post request to the authorization server. This wasn't possible before. Like a client script, JavaScript, couldn't like do a request to that other server. But now that we have support, of course, in browser, we shouldn't really use this flow. There are a better solution. And then talking about the end there, that's the proof key for code exchange. That's also a mouthful. It's abbreviated PKCE, but it's actually pronounced Pixie in the specification. So I'm going to call it Pixie because it's a cool name. But yeah, the implicit flow had loads of problems. As I said, the access token is exposed in the browser. People can then copy it if they have access to your computer. I mean, it takes a bit of work to do to get the access to your browser. But maybe there could be a security hole in your browser, so other people can get information from your browser. It just doesn't install on the same device. So that's a problem. You also have stuff like something called, and I'm not going to go in very detail about the safety recommendation, but you should know that there are issues with this kind of flow. But there's something called a redirect URI validation attack, which is a problem if you use an open redirector. So what an open redirector is, for the people who don't know, is that, for example, it could be like, say your website, and then you do, as a query parameter, you can have like if success, and then you actually embed in the URL you want to redirect to. That's like named an open redirector. So then an attacker could then, if you click on a link that someone sent you an email, for example, and they could change that redirect so to go through to their site, and then they get access to that access code because, yeah. So also don't use wildcards and redirect URIs. This is often when you register a client. You should have the full callback URL. Because it does support often having a wildcard at the end, so any requests to that redirect URI will be okay when you initiate the flow. But you should always use a full URL. Like if you have 10, then register all of them. Don't use a wildcard. But you shouldn't need 10. But yeah, the general point I'm trying to make is that there's a lot of attack surfaces here, and as developers, we want to mitigate the attack surfaces. We want to reduce the attack surface as much as possible, and that's kind of the point of talking about all these different flows too. Like use the authorization code flow if you can, have a backend if you can. Like not only for this, but in general, if you have a backend, things are much safer, as long as the connection between the front end and backend is a bit secure too. But yeah. Let's talk about Pixie authorization code flow. So, well, hold on. Implicit flow was for public clients, and authorization code was for confidential clients. The Pixie authorization code flow is for public clients. It is basically semi-safe. It's safer. It's not as safe as the authorization code flow, but it's a bit safer than implicit flow. And if the authorization server that you like say Spotify or Google or whatever, supports this, and you have a public client, you can't have a backend for some reason, then you should rather use this if they support it. So let's look at it again. You click a button, but here's changes. In the client now, which is a public client, you want to generate a unique cryptographic random value, and this is known as a code verifier. This is a name. And then you hash that code verifier, for example, with a RSA algorithm, and you get a new value. And that new value is called a code challenge. And then, when you then do the redirect to the authorization endpoint, you actually include that code challenge, the hash value, to the authorization server. Then everything happens like before. The authorization server authenticates. You click OK, grant access. And note that the code challenge is stored at the authorization server and also linked to an authorization code, it should be. And then you redirect it back. But here you get a code, just like in the code flow. But this is still happening in the browser, like before. But now, when you do the token request, which is now possible because of CORS, you can then do post to the token endpoint directly in the this is still happening in browser, where you then post that code verifier, which is a non-hashed value. The authorization server will then hash that code value, and it compares it with the one that you sent first, because that was the hashed value using the same algorithm. So it's kind of like semi-authentication of the client. It's like a one-time use credential in a way, if you want, to think about it. Like, because before, the client here would send its password, but you can't do that because it's a public client. Instead, you generate kind of like a temporary one-time use password. Again, it's still happening in browser, so you do have some risk, but it's safer than just returning the access token directly. And then you get the access token. All right. See how much time we got? Okay. OpenID Connect. Let's talk a bit about that. So that is a protocol for authentication. And authentication, as I said, is about asserting that, making sure that someone actually got authenticated. This introduced something called an ID token, a bit similar to the access token in sometimes. It's not really, but that's some kind of token that contains information about when the person was authenticated and who did it and stuff like that. And this one also defines some flows. As I said, it's built on top of OAuth, so the flows will look similar. You got an authorization code flow, which is basically exactly the same, just that in addition to the normal OAuth flow, you include a scope called OpenID. That's the only difference. And then you get an ID token back in the token request. It got also an implicit flow, which is basically the same. Again, the same flow. It's just that in addition to the access token and refresh token in that request, you also get an ID token that contains information about the authentication. And then it's a hybrid flow, which is the ID token is returned like the implicit flow, but if you want to get the access token, you have to do a backend request. Personally, again, use the authorization code flow if you can. Use the other ones if you have to, but know that you are then there is some risk involved. And that might be okay in your solution, really depending on the data you're accessing and how secure you want to be. But yeah, if you see the button like this, sign in with Google and sign in with Microsoft, it's usually OpenID Connect. It doesn't have to be, but it's usually OpenID Connect that's happening behind, especially in this case. So yeah, as I said, the authorization code flow for OpenID Connect, since it's built on OAuth, it's the same flow. It's the same. You're still using kind of OAuth, but you're adding an extra scope called OpenID. So here in the scope list, we have added OpenID. And then it also defines the specification, also defines some other scopes, like profile and email and address. There's lots of scopes, and depending on what kind of information you want about the user, you can also get information about the user, and not only information about that the user actually has gone through a login process or authentication process, that is. Yeah, again, this is the other parameters here are the same. The state is still there, you can still use it, you use response code, so the only difference is that scope. There's also another one that I hasn't actually shown here, because it's not required, called a nonce. That's a bit like the state. just that instead it is returning a request. When you get your ID token, it will be included in that list. We're going to look at it. Yeah, and then you get it back just as before you get a code. Like the flow hasn't changed. It's the same flow. However, when you then do a post to the token endpoint, you get the ID token as well. And you see here written AAA, and some people might recognize what that might indicate. Coming back to it. So it's very common that most OpenID Connect providers also offered a JSON document which contains basically metadata, configuration data about the client, like where do I find, like what's the address for the endpoints, which features do you support, where can I find public keys so I can validate signatures. We come back to that. But yeah, so when you configure your endpoints, like in your client application, when you write, okay, redirect to this authorization endpoint, you shouldn't just really hard code that value. You should go to this OpenID Connect discovery endpoint, which is available at this address. It's basically the issuer, which hopefully you know. There are ways in, and then you just add well-known, it should be a punctuation mark here, .wellknown / OpenID configuration. The request there, you get this big document. This one is actually for Google. This is the one that Google returns. Interesting things, you should also check that the issuer is the same as the host where you did the request. So yeah, this is accounts.google.com, looks good. Here's the authorization endpoint I was talking about. There's the token endpoint. Okay, sure. Userinfo endpoint, something that we need. This one is where the JWKS underscore URI is where you find, if you're familiar with JSON Web Tokens, is where you find like the public key information, basically. But also this one, like response type supported. Okay, they support the code flow. That's authorization code flow. Token is actually means they support implicit flow. And then they have lots of other here that can be combinations. I'm not going to go in detail that. But yeah, and also which claims they support over this protocol, like email. Okay, you can ask for email and family name and given name and stuff like that. So the ID token is a JSON Web Token. And due to time restrictions, I'm not going to go into details how JSON Web Tokens work. But basically, it's something. JSON Web. There are two types of JSON Web Tokens. There are signed tokens and JSON Web Signatures and JSON Web encryption. So you can have a JSON Web Signature without any signing algorithm. But basically, what it means is the JSON Web Token contains three parts. You have a header, which tells you which algorithm, like if it's a sign, because ID token always are signed, but they can also be encrypted. But usually they're just signed because you get enough encryption by sending it over HTTPS. So the JSON Web Token have a header component which tells you which algorithm was used for creating the signature. You can go to that URI that's defined here to find public key information that you then can use to validate that signature. But yeah, that's a bit outside the scope of here, but you should always validate that signature when it returns. But yeah, so lots of these kind of like claims, as they're called, they are just coming directly from the JSON Web Token specifications. Like who issued it, this ID token, who the subject identifier. That's kind of important. This is an internal ID that the authorization server, say Google for example, has for this user. It's unique for that user only, but it doesn't need to make sense. Like you shouldn't use an email for an identifier, for example. But it's it's the internal user ID basically in the system you're talking to. Then it's the issuer. You should always make sure that that is the same as you asked, where you did a request. When it tells you information about stuff like when this token cannot be considered valid anymore, when this information be outdated, it tells you when it was issued. It also tells you information about when the user logged in, like when the authentication happened. Because as I said, primarily an ID token should tell you about that some kind of authentication happened. It's not about just getting information about someone. that's like a side component, really, of the ID token. It's more about verifying that they actually was authenticated, that they actually logged in or somehow else proved their identity. And you can then see when it happened. But yeah, it can contain other information, like name and family name and stuff. That depends a bit on the application. So yeah, usually though, like name and email and profile information or website or whatever social kind of user information, profile information, it's usually found at something called a Userinfo endpoint. So this is just a resource. So you actually use the access token you get to talk to this endpoint. So that's basically an OAuth 2 resource. Like, depending on which scope you ask when you initiated it, you then get like some information back about it and about the user. So this is like profile. Right? You got the sub that always need to be returned. That's, as I said, internal user ID. But then you get, for example, the name and the family name and the email. So so as I said, primarily an ID token should be verification that the authentication happened. And then the user info is where we actually find information about the user as an addition. Yeah. So I would advise everyone, especially if you're new, but also if you just want to play around a bit. So Okta and Auth0, they are both kind of big, very famous OpenID Connect providers. They both have some playgrounds where you can basically go in and click and look at the different flows. It's simulated, and you can see every step I go through, but in a more kind of like developer-friendly way. So check out those URLs. You could also, like Spotify and Google, they also have kind of like playgrounds or web consoles where you basically can try the flow in the browser. That's usually an implicit flow though, just keep that in mind. So be a bit careful with that, but then you can test it out before you kind of like, without needing a full application. Yeah, so that was all I had. So thank you for attending. And if anyone has a question, we have maybe a couple of minutes for that. Yes?
Yeah, thanks for that presentation. This is more like a question or comment, but I think OpenID actually got a few years back the European Union's approval of authentication method.
Ah, that's great.
And that's why I think it's quite often used in strong authentication systems like CPAP and such.
Yeah, and I think also it's especially if you use, like, say, the authorization code flow, it is a quite secure way to get approval. And one point I want to make is like the OAuth 2, there have been people who've been using, and that's what I did in the beginning before OpenID Connect existed, who used that for some kind of proof of authentication. Because the kind of thinking being like, well, you did go to the authorization server and you did some authentication there, so can't I just assume that you've been authenticated? But that's a very dangerous assumption to make. You shouldn't use OAuth as like an indirect way of thinking, okay, the user's been authenticated, because you don't actually know that how they got authenticated. And yeah, so that's an important point to make too. So use OpenID Connect if you need authentication. Any other questions? Or, yeah?
Yeah, so this might be outside of the scope for this talk, but there's a YouTuber that I follow, and he was hacked like before the new year by clicking a link that copied his Google session token. I'm just interested in, do you have any thoughts on how that's even possible?
Most likely, if either, like if you get access to a session token, which is outside the scope of this whole talk, yeah. But as you said, but that's usually, like, because that's what everyone is doing, they're creating session tokens. Usually, there's two ways this could happen. Either the people making the application in question, was it a Google account? Yeah. So this is very unlikely, because I would think like, okay, maybe they done something, they provide like not sent a secure cookie, for example, where they store the session token, because usually it stores just a session ID and all the session information is stored in the backend. But if this was Google, that's probably not it.
Because it was connected to his YouTube account. So
Yeah,
the
but
attacker got
but
access.
it's just more that I really trust Google. I think they know what they're doing.
Yeah.
So I don't think it's that. Then it's more likely that he's got some kind of like malware that, or like some kind of program or something that either used a browser exploit or somehow got access to things inside his browser. Because there's no really way of. There's probably a comment here too, or is there any question?
No, it's actually like that sounds quite a lot of like cross-site scripting. So somehow they
Yeah.
embedded some JavaScript that actually when press the button actually copy or run some JavaScript.
Yeah, exactly.
And then send that information to somewhere.
Yeah, that's also possible if you manage to redirect the user forward. Thanks for the comment. Yeah. All right. But okay, we don't have more time. But if you have any more questions or just like to talk about this, contact me. I'll be happy to discuss. And yeah. So thank you for coming.